Good morning, everyone. I welcome you all for this AI Pathshala for forecasting and optimization. AI Pathshala is a series of technology workshops, designed for the developer community that facilitates peer-to-peer interactions led by technology experts in data science and AI, right? And these cover various topics in the areas of NLP, computer vision, high performance computing, and product development. And in fact, AI has, as everybody knows, seen a rapid adoption in recent years, and forecasting and optimization is a very important pillar of the AI umbrella. In today's workshop, we will understand what forecasting and optimization is, and we will go through the use case and application of forecasting and optimization to solve real industry problems. And we will detail out on how to implement simple forecasting technique using optimization method in Excel. And we also would discuss on one of the key performance metrics for validation of the model build. Now, it is my extreme pleasure to introduce the speaker today. We have Rajeev Ranjan, who is AVP Data Science at Genpact. So Rajeev brings around 15 years plus of experience in AI, ML, and data science, and he has varied experience in implementing AI, machine learning, data science in domains of CPG, electronics, media, hospitality, entertainment, and insurance, and so on. Now, in his current role in Genpact, he is responsible for leading machine learning and based engagements for various clients. His team is responsible for delivering projects by implementing high-end machine learning algorithms, techniques, leveraging latest available technology, and bringing impactful insights, recommendations for the customer. In fact, Rajeev has a patent in the field of reinforcement learning, system and method for reinforcement learning based on onloading optimization, and he holds a master's in applied statistics from IIT Bombay and bachelor's in mathematics from ISI, or Indian Statistical Institution. With that, Rajeev, I hand it over to you, and we are looking forward for a great session. And before I pass it on, for everybody who has joined in, any questions related to the session, please key in the question and answer panel. And we have a colleague of Rajeev, Shayantan, who would be responding to you in the Q&A panel. So you will get live responses in the Q&A panel. And anything not related to the topic, you can always chat with me in the chat panel. So any questions related to the topic, we do it in the Q&A panel, and anything not related to the topic, we do it in the chat panel. And Rajeev, before I hand it over, so since it's a 4-hour long session, what we planned is every 45 minutes to 50 minutes, we'll give a 10 minutes break. Nobody has to log off, and then you come back in and Rajeev begins with this session. So since we are starting at around 10:05, our next break would be coming out at 10:55. All right, Rajeev, over to you, and looking forward.
Thank you so much, Sudeep. Thanks for a very nice introduction. Okay, I know it's a 4-hour for 2 days, so maybe it seems to be long, but believe me, when we move forward, it will not look like as if it's a very long session. We'll try to be as creative as possible, and we'll try to see different cases, different use cases, and different scenarios, and understand from the ground level what and where to and how to do the forecasting, optimization, machine learning, and all those things, right? So thank you for joining. I welcome you all. I know we all understand that AI is a very important field nowadays in every aspect, but we may not understand what are all the different things that comes under AI, right? Artificial intelligence is a very broad terminology, and many things can come under this, and we always get confused. Maybe forecasting is one of them. Is optimization also part of that? Is something also involved in AI? So what I'll suggest everyone that either we all will go to a YouTube channel from our side, or you can see my screen, okay, and we'll all try to uh, fetch one information that, okay, where is this AI? So if you type YouTube, you'll see, I'm sorry. So when you go to YouTube, try AI in 5 minutes. Okay. You can look at my screen, or if you want to try at your end, try at your end also. We'll just watch this video. It's a very
Rajeev, you might want to share the computer audio because we cannot hear the computer. You stop sharing and then.
okay. Is it not on?
No, we can't hear the audio. So when you're sharing, you first stop sharing.
Okay.
Okay, and when you click on that share button, it will give you an option to share computer audio. And at the bottom, you'll get that. Did you get it?
Not really.
No, when that Zoom share screen comes in at the bottom, you stop sharing again. Now click on that up arrow, and at the bottom of that screen, you'll see a checkbox. It says share sound.
Yes.
Okay, now you share it, it should come.
Artificial intelligence for people in a hurry. The easiest way to think about artificial intelligence is in the context of a human. After all, humans are the most intelligent creatures we know of. AI is a broad branch of computer science. The goal of AI is to create systems that can function intelligently and independently. Humans can speak and listen to communicate through language. This is the field of speech recognition. Much of speech recognition is statistically based, hence it's called statistical learning. Humans can write and read text in a language. This is the field of NLP, or natural language processing. Humans can see with their eyes and process what they see. This is the field of computer vision. Computer vision falls under the symbolic way for computers to process information. Recently, there's been another way, which I'll come to later. Humans recognize the scene around them through their eyes, which create images of that world. This field of image processing, which even though is not directly related to AI, is required for computer vision. Humans can understand their environment and move around fluidly. This is the field of robotics. Humans have the ability to see patterns, such as grouping of like objects. This is the field of pattern recognition. Machines are even better at pattern recognition because they can use more data and dimensions of data. This is the field of machine learning. Now let's talk about the human brain. The human brain is a network of neurons, and we use these to learn things. If we can replicate the structure and the function of the human brain, we might be able to get cognitive capabilities in machines. This is the field of neural networks. If these networks are more complex and deeper, and we use those to learn complex things, that is the field of deep learning. There are different types of deep learning in machines, which are essentially different techniques to replicate what the human brain does. If we get the network to scan images from left to right, top to bottom, it's a convolution neural network. A CNN is used to recognize objects in a scene. This is how computer vision fits in, and object recognition is accomplished through AI. Humans can remember the past, like what you had for dinner last night. Well, at least most of you. We can get a neural network to remember a limited past. This is a recurrent neural network. As you see, there are two ways AI works. One is symbolic-based and another is data-based. For the database side, called machine learning, we need to feed the machine lots of data before it can learn. For example, if you had lots of data for sales versus advertising spend, you can plot that data to see some kind of a pattern. If the machine can learn this pattern, then it can make predictions based on what it has learned. While 1 or 2 or even 3 dimensions is easy for humans to understand and learn, machines can learn in many more dimensions, like even 100 or thousands. That's why machines can look at lots of high-dimensional data and determine patterns. Once it learns these patterns, it can make predictions that humans can't even come close to. We can use all these machine learning techniques to do one of two things: classification or prediction. As an example, when you use some information about customers to assign new customers to a group, like young adults, then you are classifying that customer. If you use data to predict if they're likely to defect to a competitor, then you're making a prediction. There's another way to think about learning algorithms used for AI. If you train an algorithm with data that also contains the answer, then it's called supervised learning. For example, when you train a machine to recognize your friends by name, you'll need to identify them for the computer. If you train an algorithm with data where you want the machine to figure out the patterns, then it's unsupervised learning. For example, you might want to feed the data about celestial objects in the universe and expect the machine to come up with patterns in that data by itself. If you give any algorithm a goal and expect the machine, through trial and error, to achieve that goal, then it's called reinforcement learning. A robot's attempt to climb over the wall until it succeeds is an example of that. So there you go. Thanks for watching.
Not sure if we all could understand what it all meant. I just tried to give you a glimpse of different things that fall under artificial intelligence. It's a big umbrella: computer vision, speech recognition, NLP, forecasting, classification, prediction, regression. Many things comes under that umbrella. And forecasting is one of the strong pillar, I would say, under that umbrella. Forecasting is required in almost every field, right? So we are going to study or understand about forecasting, but actually in turn we are trying to understand an important part of artificial intelligence. So let us understand that artificial intelligence and forecasting is strongly connected, right? Same thing, the video just now we saw described in a visual manner, not in a video but in a pictorial manner. You can see that there are many pieces that falls under AI. AI is like a parent and it has many children, many leaves, many branches, and so on, right? Deep learning, predictive analytics, classification, natural language processing, information extraction, speech to text, text to speech, right? Planning, scheduling, robotics, image recognition, machine vision, all those things are actually trying to, together they are forming a big chunk of artificial intelligence. So it is just like, I mean, as we heard in that video also, the dream of artificial intelligence is to have machines as intelligent as you or me by mimicking the human brain. That how we take decisions, the machine should be able to take decisions so that we don't have to worry about and they will do all the work for us, right? So AI is a big part. Forecasting and other various techniques are children of that AI, and we need to understand those children to understand the entire AI. I know that we cannot understand all the children to understand the full AI, but we can always try to say focus on one or more of those. And forecasting is one of them, and we'll try to focus on forecasting today. Now, forecasting is one of the piece in that prediction world. So what is it that when we thought about AI, and inside that AI we are trying to do machine learning, and inside that machine learning, what are different type of analytics or data science, data understanding we can do? So ideally or generally we think that there are four main bifurcations you can think of about the analytics, and we can start from the bottom one, which is descriptive. You can always take a data and try and understand in terms of describing the data. It is just like, I mean, somebody is trying to visit a doctor and doctor is trying to describe his or her health conditions, right? So it is describing what is the current blood pressure. Similarly, what is the current sales of a product, right? So current situations, descriptions can be understood, right, by describing the data. Then we can try to even diagnose the data. I mean, how and why can we understand why things are different? For example, I mean, why is data can tell you that sales of ice cream is very less in winter month, right? Winter time period, more in summer. So these are diagnostics. We can do some data understanding about it and trying to understand the different reasons coming out from the data. Till the descriptive and diagnostic piece, the prediction doesn't come. The actual machine learning doesn't start. The machine learning piece starts from the predictive world. So here you will try to use your historical data and trying to predict, forecast the future, right? What is likely to happen. Now, once we have done the prediction, do we sit on that prediction? No. We do the prediction. It is just like, I mean, doctor can predict something for a patient, but then that prediction may not be the end, right? It's like, what is the next step that we can do? There comes the prescription. And prescription is the planning, actions, strategy building, all those things that should happen based on the output of the prediction. It's like prediction, if the prediction is like antigen test is predicting that somebody has COVID, it means the prescription will start. Need to get hospitalized, need to do this, need to take medicines, need to take rest, and so on. So that planning, strategy, building, all those things should start after the prediction happens. So the life may not actually stop at prediction. That's why the prescription is one of the most important piece. That's why the topic for today is, I have named it as forecasting and optimization. Forecasting will try to address the predictive piece, and optimization, recommendation, strategy building, all these things will try to answer the or refer the prescriptive piece, right? So it's like descriptive, diagnostic, predictive, prescriptive. Prescriptive is once you have the prediction in hand. That's why we need to understand all these four layers very carefully whenever we have a data with us and we are trying to answer some of the business problems using data science activities, right? Now, I know, I mean, we are here to study about forecasting, but I'm just trying to connect that. Okay, I mean, when somebody goes to forecasting, what are the different keys? Before that, we all should understand forecasting. As I said, forecasting is just one of the child of that AI or the machine learning. Whenever we are trying to do any machine learning piece, it means data description, data science, data mining, all those things are involved, right? So I have just tried to describe here what are the different informations or expertise we need whenever we are trying to solve any data science, data based, machine learning based problem. Not necessarily that it has to be a forecasting problem. Forecasting is one of the machine learning techniques, right? Overall, what is it that we all should be doing, right? So let us start from the right rather than the left. Data, most important piece. If we do not have data, there is no point in doing data analytics, data science, data mining, and machine learning based on data. We cannot do anything. So data is the most important piece. And that's why, I mean, the terminology is coming like data is the new oil and so on, right? Everything will run on data. And everybody is trying to gather as much data as possible because they want to understand it and make different business strategy and many different things, right? So data is the most important thing. Unless we have data, we may not actually proceed with any data science or machine learning activities. Now assume that we have data. Do we know what to do with that data? In a very simple term, I have data for every individual in India. Assume, I mean, because Aadhaar is there. What can I do with that data? Our government wants to know the average salary of entire country. What is it that we should do? Should I take the average of everybody's salary? Should I take the median of everybody's salary? What should we do? So that what should we do? Should we do, in a very simple term, I said, should we take average or should we take median? Or should we do twice of the salary? What is it that calculations, what is it that techniques we should apply on that data? So that's why the second piece that becomes important is, do we know what techniques to employ on that data to arrive at some answer or to arrive at some relevant answer, required answer? I mean, we cannot do a very different type of calculations on the data and it doesn't answer our real business problem. So techniques related to the business problem we are trying to solve. So technique is very important once we have data at hand. And forecasting is one of the technique. Many people who are from this machine learning world, they may understand linear regression is one of the technique. Random forest is one of the technique. Decision tree is one of the technique, right? There are n number of techniques for classification. There are n number of techniques for regression. There are a number of techniques for clustering and so on. So these are techniques. So we should know what techniques to employ once I have data and the business problem at hand. Now, even if I know the technique, as I was giving the example of India, 138 crore population, right? 1.38 billion population. And even if we have informations for everybody, and I just needed to take average, can I do that average on a piece of paper? I can, given that I have infinite amount of time with it. It means only knowing technique may not be sufficient, may not be enough. Technique is one of the necessary conditions. I mean, we should know techniques, but is it sufficient? No. That is why, I mean, I always say that then we need the help of technology. And technology is something that will try to make the use of techniques easier. And when I say technology, it means simple calculator for me. When we are doing a calculations, we can use calculators. We don't have to do it on piece of paper. Now, in terms of machine learning, data science, and all these things, that calculator is nothing but different platform tools that we have access to. R, Python, AWS system, right? Google platform and all those things, various technologies that is making our life easier in terms of executing and employing the techniques we know and techniques we want to use to come up to an answer, to a solution, right? So that is the flow, data to techniques to technology. Now these three are like very I will say core piece in terms of technology, technique, data. Now there is fourth angle to it, which is not very objective in nature. It is not like it's a very plain calculation. It is like domain experience, and this domain experience may not come in 6 months, may not come in even 1 year, right? It takes huge amount of time to have a domain expertise built, right? So that why domain expertise is required, it is just that if somebody is trying to solve a business problem using a data, and he was told or she was told that the data is from the chocolate industry, and that person built the entire models, used the best of the technology, best of the models, and come up with a solution in terms of prediction and prescription. Just before delivering the result or coming up with the conclusion, that person was told that by mistake the business topic or the business or the domain was wrongly mentioned. It was not a chocolate industry. The data was entirely about the car industry. Do you think that whatever we have done from data to technology, it's correct and we should just publish whatever result we had received? My answer would be no, because the domain for chocolate and domain for car is very different, right? So we have to think about the output, about the technology, about the data, everything with respect to the domain that is there in our hand. Telecom business may not behave similarly as the CPG business, right? So forecasting, although both may need forecasting, but they both need to be treated differently. And the domain expertise, as I said, come with experience. I mean, if you ask my personal experience, I always thought that it's probability which comes with experience. In school, you will always do more error. The moment you have more experience, you will start doing less error and so on. So with the time and experience, you will be good at probability. Domain is like one of them. More you understand the domain, better confidence you will have on your answers, response that you have generated through the mathematical, statistical, economical models that you have used in building your algorithms, and your journey is starting from data to techniques to technology, right? So domain is also one of the important piece. So data, technique, technology, domain. And again, I mean, there has to be a fifth piece also, I mean, which is like common sense. I mean, that piece should always be there. I mean, we should not blindly believe on the result. The common sense is the fifth piece, I mean, is missing, but yeah, that's understood. We all should have that common sense whenever we are trying to solve any business problem that needs some interpretation in terms of data, technique, technology, and domain piece, right? So when we understand all this piece, we understand that, okay, I am able to answer some of the business problems that needs machine learning based address, right? That needs to be addressed via machine learning technique. And forecasting is also one of the machine learning. So forecasting also, we need to understand the data, and we need to understand the techniques. We need to understand which technology I'll be using, and we understand we need to understand what is the domain we are going to work for or we are working for, right? Now, nowadays, you will hear a buzzword in the industry, which is called MLOps, right? Just like DevOps, now MLOps have come. machine learning, right? And it's many people need to read, understand, and do too many reading to understand what it is, and also to execute to really experience it. I have tried to capture that ML ops piece in a very small format so that we all understand that what is the ML ops, and forecasting is one of the component, or machine learning is one of the component, or building algorithm is one of the component inside the ML ops, right? So this picture you can understand as if the first blue ball that we can see, the data management, it you can think of is the one of the bun of a burger, okay, and last blue is also the another bun of the burger. So burger is not, it cannot start unless you have the first bun with you in your hand, right? And that is like data management. So data management, before you start employing any science or any algorithm, we need to understand how do we manage the data. Where is the data sitting? Is it in the correct format? Do I need to do some data modeling? Do I need to bring it into a format that can be consumed by the machine learning model, or say algorithm that we are trying to use on the data? So data management, data modeling is also one of a very important piece. If we do not understand that piece, the burger will not be complete. It will not even start, right? So that is the first one you can think of. Middle piece is like, in our scenario, I have specifically kept forecasting. You can think of any machine, you can write any machine learning algorithm there. Forecasting, I have just kept it for our discussion. You can replace forecasting with machine learning, right? So forecasting and optimization, these are two of the, I will say, the ingredients inside the burger that you want to eat, right? That makes the things actually eatable. You don't do it bun alone, right? So you need some recipe, some spice inside it to make the burger tasty. So forecasting and optimization, you can think of those layers that needs to be put inside the burger. So forecasting, optimization, we have to build machine learning algorithm. The science comes into the picture, the algorithm building activities comes into the picture. Again, it also needs the technology and all those things. As I said, R, Python, Google, AWS, everything are there, Amazon, all those things that you can use to have a forecast. And then on that forecasting or on the output of machine learning, you can do some optimization or recommendation or prescription. So forecasting you can replace with prediction, optimization you can replace with the word prescription. So these two. Now once all these pieces are there, I mean, how do you serve the recipe? It is like that. So the third component is the second one, that is deployment or MLOps that we call it, right? So deployment, whatever is the science we have built, the algorithm we have built, how that output can be deployed for the customer consumption, right? Google Map may have best of the algorithm sitting behind it, but the way it gets displayed to all of us, everybody's phone has different its own map, right? So it's like deployed. That algorithm is deployed. So that deployment is also necessary to finish the entire stretch, right? That's why, in short, if you want to understand the MLOps picture, it's like data management, model building, deployment. And when I say deployment, it's not that you will deploy and leave it. I mean, Google must have tested, validated, right? Some hypercare must have happened and so on, so that correct information is displayed, and it is displayed in a correct format. People understand it, they are used to it, and so on, right? So this is like data management. Then we have model building activities, and then model deployment activities, right? So I mean, whenever we are trying to solve any machine learning problem, although we may not be directly responsible for the data management or deployment, maybe, but we should always keep that piece also in mind, so that, because these three are interconnected, right? I mean, nobody is living without each other. I mean, so we have to understand that how they can be stitched together, so that whenever we are framing the solution, we should keep that mind, so that it is easy for the integration purpose, it is easy for the deployment purpose, and so on, your output. Right? I'm not taking up the questions. I am assuming Shanthan is trying to respond to. If there, I mean,
that's right. Rajeev, Shanthan is responding to the questions.
Okay, thanks, Sudhir. Now we are coming to the forecasting. To be specific, inside the machine learning world, forecasting, as I said, is one of the important piece. So now onwards, our discussion will be mainly around forecasting. Now, forecasting, if you think it, no business is there nowadays which doesn't do forecasting. And by the way, forecasting is not something that we have started, the world has started recently, right? We all have been doing forecasting, but we didn't know that we were doing forecasting, right? I mean, since long ago, I mean, people used to buy grocery items. So the timing of buying them grocery items for the home, always there is some forecasting at the back of mind, so that you buy so much kgs of rice and different type of food materials, right? So it's like forecasting. You have already done, okay, this since last month I consumed this much, next month also I'll consume similar amount, so I should buy that, and so on, right? The only piece was not there was that we were not doing it scientifically by trying to actually calculate using technology, using technique, and then come up with result. We were doing it in a different way, but it was there. So now, if you read that 85% of manufacturers recognize the role of digital technologies and the potential of industry 4.0 to increase asset efficiency. Unless we know the forecast number, I don't know how to utilize my resource to meet that forecast. If my forecasting numbers are less and I have too much of resource, my resources are sitting idle, right? If too much forecasting is there, the numbers are very high and resources are less, it means I know I will be short of meeting the demand and so on, right? So you will see that in industry, all those numbers that you see on the screen is very relevant today, and everybody is trying to do forecasting in some way or the other. Again, we know that forecasting is not easy. I mean, it is very easy to say that, I mean, iPhone sale will be this much in 2022, but actually when you compare yourself, when you reach in 2023, there will be an error. But what can be our best guess? What can be our best forecast, so that the manufacturer is ready with that? Manufacturer doesn't want to incur too much cost, right? Next, I'll just it is about the demand piece. So if you look at this, if you improve the accuracy in forecast, when I say improve forecast accuracy, means that the error in your forecast is less. As I said, if the error in our forecast of iPhones in 2022 is less, it means the cost for that company to manufacture the iPhones will be very optimal. They will not have incurred more cost by building more phones, even though there was less demand. And at the same time, they will not miss the profit if they were planning to manufacture less, but actually the demand was supposed to be more, right? So improved forecast accuracy, if our forecast accuracy is better, it will improve resource allocation to maximize revenues, right? Your resources available to manufacture or to align your resources with respect to the demand will be better utilized, right? And you will have different type of things, like our decision will be data driven decision, right? It is not like something very subjective, because that I think this is the answer, I think that is the answer, and so on, right? So data driven forecasting may lead to or should lead to improved forecast accuracy and that will lead to better use of resources, better use of your strategy building activities, and so on. You will have a better strategy being built for the demand or the forecast number that you see, right? Again, there can be different types of algorithms in forecasting that we'll discuss one by one, and we'll start from the ground zero. I mean, as if we don't know anything about forecasting, and how do we actually start with this. But yeah, I'm just trying to make sure that we all understand that forecasting accuracy is very difficult to meet, or I should say good or great forecasting accuracy is very difficult to meet. But yes, should we be sitting idle? No, we should try and leverage the data and the technique and the technology as much as possible to arrive at a better forecasting accuracy, and then to help the business take better decisions and make better strategies, right? Some of the industries I have just mentioned, again, these are not exhaustive list. I mean, n number of industries are using forecasting, and they are trying to leverage that to improve their business. So if your forecast accuracy is better, your forecasting is good, it can reduce your logistic costs, right? Enhancement in customer and user experience. For example, you know that there will be 1,000 calls at, say, Airtel call center today, and you have enough people available to take those 1,000 calls, then you are actually meeting the customer satisfaction, right? So it means you will have enhancement in the customer experience. Enhancement in order fulfillment. If we know the demand beforehand, we will try to fulfill that order, right? So that the customer is not dissatisfied. Improvement in demand forecast, so that you can utilize your manufacturing plants resources if we know the demand forecast correctly, right? Lower financial contingencies, better asset utilization, process standardization, better inventory management. If we know that what is the, if somebody forecasts correctly, I mean, why then you don't have to keep too much inventory in stock, right? Inventory is kept because we know that there can be some surprises, and I should not be running out of the stock if I don't have enough inventory, right? I mean, we always keep some, say, even at our home, rice, we don't finish it, we keep it in inventory, and before that finishes, we go and buy it. Inventory means so that the surprise should not disturb us. But if we know the forecast correctly, that inventory management can be done intelligently, right? Operating cost can be reduced. Process efficiency in collections can be there, right? In collections, when I said you are trying to collect collections in case of insurance and all those things, right? So various industry, I have not mentioned all industries. There can be n number of industries where forecasting can be used, and forecasting actually is being used, right? So I'll post this. I'll just walk you through one of the use case that recently I and my team solved, and actually we are about to close it. So it is about forecasting and recommendation. So it is about an industry which actually rents out big refrigerated containers for medical say medicines. You need to keep medical medicines safe, and maybe you want to transport those medical medicines in a correct environment. So you need that refrigerated, those big containers, and you put your medicines inside that, and you try to export it. And that company rents out those big containers, I should say. Okay. and everybody who uses that, they don't need to buy that containers. They just takes it on drain, use it, and again after use they deposit it at the relevant their center. So here the company wanted to understand the demand. The company which is trying to rent out is trying to understand the demand for the containers that needs to be rented out at different locations. And actually it was around Europe and US locations. So you will have n number of cities, right? And every city will have different requirement. Based on the historical data, can we forecast the demand for next week at each of the locations? Now what happens is that you will have demand for each of the locations in the history. Maybe you client will give you, or client had given us 3 years data. Try to use that data and forecast the number of containers we need at the end of the next week. And what happens is that the real piece is that, okay, you may have used the best of the forecasting technique, best of the technology at hand, and you have understood the data perfectly, and you have forecasted. Maybe your forecasting accuracy is also very great. Now, once you have done that forecasting, do we really stop at that? The company has a different problem. That if, say, again, I'm throwing an example in this same scenario, that if the demand for the containers at London next week is 50, but the demand for the same type of containers, say in Paris, is 100, it means what? It means if I have forecasted 50 for London and 100 for Paris, I need to make sure that I have 50 containers available in London and 100 containers available in Paris to meet the customer demand. Right? Now, what happens is, look at the scenario and hear the scenario out. What happens is that for some reason in London, I have this week, I have 70 containers available. And in Paris, I have 50 containers available. Now, totally in the initial scenario, London plus Paris needed 150. Now, London plus Paris here is 50 plus 70, 120. It means totally I am sort of 30, right? But actually, if you look at, you are not actually sort of 30. Paris is needing 70, it has just 50. So actually 50 is not there, and London has more, right? So it means company wants to understand that if I start transporting the containers from one location to other, just because other location may have more requirement than the previous location, what is the best cost that I should incur to meet the maximum demand for my product? Now, I just gave you an example of just 2 cities, London and Paris, but actually there are 100 cities, more than 100 cities. Now, to understand, and every 100 cities will have a transportation cost. Every lane will have a transportation cost. London, Paris, there will be a cost. Paris, Hong Kong, there will be a cost. So every, I mean, think about many combinations. And we have to try to meet the demand at each of these 100 locations. Now, forecasting has given me the demand, but the optimization should be able to help me meet that demand, believing that the demand is correct, which is coming out from the forecast. It will help me meet that demand using the least cost of transportation. So this is the problem we try to solve, first using the prediction, which is called forecasting, and then the prescription, that is using the optimization. right? So that's why I said forecasting and optimization are not actually a different piece. We need to understand that, okay, should we stop at forecasting, or actually there is something more to do? Forecasting is just a means, not the end. What do you do with the forecasting? So this is one of the very easy and understandable use case where you understand that forecasting is not the end. You understand the forecast, but how do I meet the forecast? Then I need the recommendation. So building the recommendation engine may take time. We may have to understand the optimization. We may have to understand the mathematical structure and so on. I'm not getting into that. So I just wanted to make sure that we understand this use case. For a customer, we were trying to solve their inventory problem, their transportation problem, so that transportation cost is less, and at the same time they are trying to meet the maximum of demand with whatever containers they have in hand at different locations. I will just take a pause. So Sudeep, I need to go through a different one more use case, but I think we should take a 10 minutes break and then maybe we should reconnect.
Sure, I think that makes sense, Rajeev. It's 10:54 by my watch, and we can all come back in another 10 minutes from now. Yeah, so 11:05 we get started, and I would request that if you not log off, you just come back after 10 minutes. Exactly at 11:05, Rajeev would start the session. All right.
Thank you. Okay.
There you go.
Okay. Maybe I'll try and answer some of the questions that I can see in the Q&A. Okay. Around the use case actually you are talking about. So one of the question I could see is that manufacturing industry is lagging behind in forecasting. I would now say that it is not the case now. I mean, manufacturing industry have also started embracing the forecasting, because it is one of the most important piece. I mean, the manufacturing industry should actually use it, and they are actually using it. And why? Because you always need to utilize your plant capacity in a correct format, right? In a correct way, optimized way. Because you know that, okay, I mean, I may have some of the constraints, like I cannot manufacture less than 100 packs in a day. I should not be using I should not be keeping my plants idle for more than 7 days. Otherwise it will need again a new setup or some new start expenditure. The fixed cost will again start coming into more. So I think manufacturing industry is also coming into, I mean, they have started. I mean, I have worked for some of the manufacturing companies, and I have done enough forecasting work for them, particularly in the consumer electronics world. I have done the forecasting, and I could see them embracing it. But if it seems that they are lagging behind, I'm sure this is mostly because of the mindset, or the data is not getting captured for that manufacturer. And again, that definitely doesn't need to be a big manufacturer. Every big manufacturer, every data and everything you find, they have that in place. And why only I mean, they have the data of what is that they have shipped to a retailer, as well as what is it that retailer has actually asked them. I mean, so they may not have shipped the number that retailer may have asked to them. For example, PNG may not deliver as much as the Big Bazaar is asking them to deliver, but they have all these numbers, and I have seen that. For example, I was working for one of the manufacturer which manufactures one of the world's largest tissue paper manufacturer company, and they gave me data of how much they have shipped every week, and how much they have got order from the different vendors on the weekly basis, and so on. And based on that, we had to do the forecasting for the shipment piece. So I think they are doing it. Okay. one of the question was around this use case, that reinforcement learning. See, reinforcement learning still needs to get matured, and reinforcement learning is little different than typical machine learning, I would say. The best example anybody gives about reinforcement learning, which we all quickly understand and try to associate with it, is a child trying to learn to walk. Now, every time the child will fall, and then he will understand, okay, now I have this learning with me. Now, next time he will not do that mistake, or she will not do that mistake, but maybe because of some other mistakes, again, there will be a fall. And after doing this, every time all the mistakes are overcome, and then you will see that the child is able to walk independently, right? This is actually the example of reinforcement learning. Or ant trying to climb a wall, right? It will fall, then again it will try, it will fall, again it will try. Forecasting is little different, if you think, than this. Many people use, I will say that they wrongly or unknowingly uses terminology that, okay, I have made the machine learning model, it will learn on its own. No, machine learning models will not learn on its own. You need to retrain that model moment you have a very different and a new data with you, because the training that has happened to that model is based on some data. So it is just like, I mean, trying to make a child learn to recognize cat versus dog. You may have trained that child with cats and dogs picture, or an actual physical cats and dogs, but then you cannot understand that the child will learn automatically when say another animal, giraffe, will come. No, then that training needs to happen with the giraffe also in that picture. The reinforcement learning is again the same child trying it, already an objective is in mind, to walk, and in doing that, the errors, that the hurdles that comes, that hurdles can be learned to avoid one by one, right? So there is a slight difference. So reinforcement learning we may not directly use for the forecasting purpose, but yes, reinforcement learning can be used to arrive at the best recommendation that I was talking about, the optimization piece that I was talking about. Many people can say that I will not solve using typical optimization algorithm, or trying to solve using, say, Newtonian based calculus and all those things, but I will frame it in such a way that it has different components like state, space, right, agent, reward, and all those things, and then I will convert it into a reinforcement learning problem, and then we'll solve it. Yes, reinforcement learning can be used to solve the optimization piece, but for forecasting, I still suspect that we can actually use reinforcement learning. Okay. Third question I could see was that the timestamp variable. We actually did not have the timestamp variable as such given. So it was like weekly. When I say timestamp variable, timestamp external variable, we did not have. We had univariate series, weekly demand for containers at each of the different locations for last 3 years, right? Based on that, you have to come up with forecasting output, and you can try many algorithms, and you can bring X from your side. Maybe if you think that I should bring some holiday pictures in mind, you can create a variable called X, and if you think that different types of holidays are behaving differently, you may choose to use 3 types of X, X1, X2, X3, and X1 may talk about, say, I mean, in Indian construct, Holi, Diwali, but X2 may talk about some lower intensity festival, and so on, right? And then we can see if these are playing any role. So X you can create, but we were not actually given any X as such. We were given Y. Y is nothing but the demand for the containers at each of the locations for last 3 years on weekly basis. Not sure if I could answer all the questions, but again, I'll continue to read your question and try to answer that.
Sure. Okay. And Rajeev, the questions which you have already answered, maybe you click on that answer live, so that takes care of it. it will move to the answered questions then.
Okay. Okay, I will.
Yeah, the ones which you have answered.
Okay. I can still see some questions, but we'll see. We'll take up as we move.
Sure. Sure, we can continue.
Okay, I'll try to answer Dr. Gitali's question. Okay. So again, we have many locations. Say I had 100 cities, and every hub or every lane there was a cost and there is a demand. So my objective was to meet the demand as much as possible with the minimum cost. So my objective function would always be to meet the demand as much as possible. So more penalty will be given if the demand is missed, and less penalty will be given if the cost is higher. But again, there will be a penalty. So when you are trying to optimize this objective function, max demand, least cost, alpha x minus beta y. X is your cost and y is your demand. Now this alpha beta is the penalty. Now I need to minimize this. This number should not be more. And what should be my recommendation based on this, right? Now I will take you to another use case from the same business, different business context. Okay, it is from the contact center workforce management world. Okay, so contact center, it was from customer whose contact center is actually contacted for the health insurance. Okay, so there are calling agents and they are supposed to take calls and all those things, right? Now those agents are supposed to take calls, and we should have a better business in terms of that. We should have optimal amount of resources that will handle that contact center, right? And when I say this, what I mean is that if we already know that tomorrow there are going to be 1000 calls from 8 to 9, it means I should have people available between 8 to 9 to respond or to connect with those calls, right? Now this problem seems to be easy, but it was actually a very difficult problem for us. And when I say why difficult, we all tried to bucket this problem into 3 P's, and I always call it hard, harder, hardest. Hard, if I look at the historical data, the calls that were answered by the calling agent, the agents at the contact center office, every call had different length. Some calls were resolved in 1 minute, some calls were resolved in 5 minutes, some calls even took 20 minutes, some even more, right? Now, even if you forecast the number of calls, each call has different length in terms of time, right? So hard part was that can we arrive at, if not one number, maybe 3 different numbers, that okay, let us assume that on an average we will have 3 minutes call, on an average we will have 5 minutes call, so that I will assign one. Even if some calls happen in 1 minute, maybe other call happens in 7 minutes, my average is less than 5, right? So arriving at a one, or say some fixed number of lengths of the call, using all those statistical tests and all those things, that what should be our best, that I think became the hard problem for us, right? Again, it is not that only mathematics or statistics or technology will solve this. we need to sit with the domain experts, we need to sit with the business owners, and they should also give you go ahead that okay, this understanding makes sense, or they have a completely different viewpoint, and so on. So you may need to collaborate with people who understand this business more, because we may only understand, say, mathematics more, right? So it's like, that's why in the beginning I said domain is also one of the important piece. So after collaborating with them, using your statistics, mathematics, your knowledge, your data understanding, data that is there at hand, and so on, can we say that okay, there were many types of calls, but we can bucket those calls into 3 types, and first type can be given as 5 minutes length, second buckets can be given as 3 month length, and third bucket can be given as 10 minutes length each call, and this will solve our call problem in terms of length. Now the second piece, I call it as a harder problem. Harder problem is, okay, I have said that okay, I have 3 types of calls with different lengths. Now I need to forecast. In call center, you always try to forecast at daily level. You try to forecast at daily level, that too at hourly level. Every hour, every day, how many calls will be there, should be there, right? And you need to forecast that. So that becomes the more granular level you are at, forecasting is that dangerous, right? I mean, average India number generating is relatively easier than average of each state. And the average of each city in India becomes even further difficult, right? So lower level, the problem becomes difficult whenever you are trying to forecast something or trying to predict something. So forecasting becomes the harder part. Now assume that, I mean, we tried to do something and we came up with a forecasting algorithm, and we said that okay, we'll go ahead with this. We measured our forecasting accuracy and it was under the acceptable range, and so on. Now once you have the forecasting done, then for those forecasts, you have the resources at your call center, right? Now those resources had, in our case, they had very different experience. When I said very different experience, some were able to take this type of call, some were not able to take some different type of calls. Some were allowed to take calls only of a particular state in US. Somebody were allowed to take calls from 3 particular states in US. Somebody would come in 9 to 6 shift, next somebody would come in some other shift, right? Somebody will have a different lunch break, somebody will have different lunch break. And when you are lunch break, you're not taking calls on all those things, right? So taking all these things into account, how do you maximize the utilization of your people at the call center? That okay, forecasting has given me this number. Now I have to meet this number, but at the same time, it should not happen that even if the calls numbers are less, it's not happen that Rajeev is taking all the calls 8 hours and say somebody else in his team is not taking any call because Rajeev alone is enough. No, there should be some uniformity, right? So better utilization of resources is met via optimization. And believe me, that optimization was one of the very complex optimization in terms of that when I had used 10% of data and I was trying to use open solver in Python and which is freely available. It took 1 minute, and with 20% of data, it took 61 minutes. And with 30% of data, it took 1 week to run. It means we realized that, I mean, it will not, the moment we'll put 100% data, it will not run in real time. It will take maybe hundreds of years. So then you need to take help of, say, commercial licensed solvers, like, right? And different pieces are there. They are fairly easy to integrate with Python. I mean, you can call them those solver. You just need to have credentials because we need to take license and so on. So now that piece gets run with the 100% data that gets run in 4 hours. So every Friday we run it, and Monday you can see, okay, what is the recommendation done, and so on. Okay, so hardest, as I said, hard is coming out with how many buckets you want, the call types and particular length, and then try to forecast each type of length. And then once you have the forecasting done, you have different skills set people sitting with different say shift timing, all those things. How do you optimally place them to take calls so that your calls are also met and your resources are also utilized, right? So this is the, I'll not go ahead with more than this 2 use case. I just thought to give you all a flavor that okay, forecasting and optimization are not actually different, they are interconnected. And why forecasting? Even non-forecasting machine learning activities are also connected with optimization, because prescription is one of the important aspect after prediction. We should not think about stopping at prediction. Your accuracy or our accuracy may be very great, but what do we actually do with that accuracy? Do we have a plan in place to take care or to utilize that information, to consume that information, leverage that information that is coming out from a very robust and fantastic forecasting models, right? I'll see if there is any. Agree, Swami. I agree. We can use Arima and all those things. The only thing is, as I said, if you are trying to forecast something at monthly level, your error will be relatively better. The moment you come to weekly level, it will become relatively worse. The moment you will come to daily level, it will be even worse. And the moment you come to the hourly level, it will be very bad, because you are trying to get yourself compared every time, right? It is just, I mean, in my lingo, it is just like passing the overall exam is relatively easier than passing each of the subject with 60%, right? So the moment you have more granularity, the challenge becomes more. And call center has a problem that hourly data comes, and you should plan for each hour and not actually plan for the month, only month or say week, right? Okay. So 2 use case we try to understand with respect to forecasting and optimization. What I'll do is I'll just, since we are planning to start from the ground zero, I'm assuming that we are not forecasting expert, or we don't know forecasting. Again, I know we may have people who understand forecasting fairly well, and they know how to use or employ a very recent or very technology based algorithms. But yeah, I'm just trying to make sure that we all understand what is it that forecasting means. So whenever forecasting comes, there are approaches, right? So you can see that there is something called quantitative and there is something called qualitative. Qualitative is something that I'll say that it comes from the experience domain based more, or some surveys that you do and all those. But quantitative is like different mathematical, statistical, economic based models that we run. That's quantitative. And quantitative will need data for sure. Again, in qualitative also, the moment you will do consumer surveys, it will need data. But quantitative, all the approaches that, whatever approach we can think of, quantitative will need data, because we need history to see what happens or what should happen or what is likely to happen in future, right? Now, whenever somebody says that, okay, forecasting, so it's like short term, medium term, long term, right? Short term is very, I mean, it's like next day, next week, next month type forecast. Medium term is also, you can say next month, quarter, even yearly is there. Long term is like when you are trying to make long term forecast, right? Okay, I need to plan for next year, couple of years, and so on. So these 3 types of forecasts are there in terms of tenure, the short term, medium term, long term. And some of the forecasting truisms that are there, we know forecasts are always wrong. and I am a firm believer. I mean, obviously, we cannot match with what is the actual number. Moment you will try to forecast something for 2022, you will see that, oh my God. And given this Corona time period, 2020 and 2021, whatever model I had built earlier, everything was wrong because COVID impacted everything. I mean, so nicely. Everything is screwed up, right? We need to now rebuild and all those things. But now a different challenge will come up once this COVID period is entirely over, or it is, I know it is going to be over. So now there will be a different challenge, which we'll talk about. So forecasting, two reasons forecasts are always wrong. Aggregated forecasts are more accurate. And when I said, what I meant is the same example. If you try to understand or forecast about India, it is relatively easier than to forecast about each state separately, right? So it is like forecasting at month is easier than forecasting at daily, because you will be now judged on daily level than on monthly level, right? And shorter term forecasts are relatively more accurate because you know that there is some recency factor which may help you generate the shorter term forecast. Long term, medium term forecast is relatively difficult because, I mean, 2019 nobody had realized that 2020 2021 COVID period will be there and everything will be wrong, right? So medium and long term general are more difficult and they are less accurate than the short term. So in terms of accuracy, short term is better, and level of data, the aggregated data will give you better forecast. And aggregated means monthly, yearly, than daily or hourly, or even in terms of geography, you can think about India versus different states, right? Now, I just wanted to make sure that we all understand this, that whenever we are trying to do any forecasting delivery process, we should understand these steps in great confidence to deliver the actual requirement, right? So problem understanding, the problem when it comes to us, problem will never come in mathematics, it will never come in statistics, problem will come in English, right? Now, do we understand that problem? Do we need to collaborate with different sets of people to understand that problem? Once we understand that problem, collaborate with different sets of people, SMEs, domain experts, and so on, understand their business, and then convert that business problem into mathematical, statistical, or economics problem, right? Then we will do the data understanding, because now data is there. Now we have understood what is to be done. So now we'll analyze data in the relevant or the same context. Then we will do the data preparation, right? And data understanding is like EDA. I mean, then we'll have the data preparation is like the final data which needs to be consumed for the model building purpose, right? Model building, so RIMA model or whatever model we want to build, forecasting model. Or this is not, again, this process, the forecasting delivery process, I will not say that it is only for forecasting, but I will say that typically for any machine learning program or problem, we should follow this structure. And once you have built the model, it should be like evaluation. And once you have evaluated it, then you need to deploy it at the correct customer site or the way customer wants it to be delivered, right? Because they don't want to understand your mathematics. They're not understanding our statistics and data science. They want to understand what is how can they consume it, how they can utilize it, how they can leverage this model piece, right? So deploy and implementation, right? Maybe app development or whatever you call it at the end, right? And you can do different, whenever you are trying to make models evaluate, we should always try to make things evaluation in 3 P's. If you look at this section, whenever the data comes, I always prefer and I always suggest that we should break our data before that model building purpose. 3 P's. One will be called as training, second will be called as validation, and third will be called as testing. Again, the percentage can be different for different people. The percentage that I prefer is 70, 20, 10. 70% is training, 20% is validation, and 10% is test. You can always play around with these percentage. I mean, there is no thumb rule to this, but yeah, this is something that I have seen and I have been following for a very long time. Now, why do we need training? Training is that, okay, if somebody is studying in a class, that teacher is trying to train that student, right? So the training will happen in the class. Now, teacher will teach for a longer time in terms of months or weeks, right? But your exam will only happen once, 1 week. So length of training will always be more. So if the way I understand training, validation, and test is like, I am trying to study my materials. That is, I am trying to get myself trained. So I will read a number of books. I will read a number of articles. I will attend a number of classes and so on. And validation is, I will try to solve past papers, past year's examination papers. I will try to solve. If I don't get good marks in those papers, it means my validation is telling me that I am not getting trained in a correct way. So I will go back and change my training. It means I will try to learn, I will change my training or studying criteria, right? Once I have made sure that my training is giving me good in validation, it means now I'm able to solve my past year's papers. Then test is like, I am appearing for the final exam now. Now, if I do well in final exam, it means whatever I have learned is the correct learning. Not sure if I was able to communicate it correctly. The difference between training, validation, and testing. Train, try to validate. If there is a problem, retrain, validate, problem, again retrain, validate. When this piece is done, please test. If the testing is passed, it means the model building activity is correct. Right? Same way as I said in exam, if our study is correct, we'll pass in the past papers, and if both are fine, we'll appear for the final 10th exam and we will pass. If we pass, it means whatever we were supposed to learn as a class 10 student, we have learned, right? And below is the different type of accuracy metrics that people talk about. I'll talk about those accuracy even later on. If it's just for that, if it is like R square, MAP, L1, L2 metric based MAD and RMAC, weighted MAP, bias, and all those things, I will take this more when we are actually solving the problem. Okay, so this is the process we should follow: problem understanding, collaboration, business process understanding, data understanding, data preparation, model building, evaluate that model, deploy it. And problem understanding is the most important. That is why I said, I mean, whatever, I mean, I'm not a naysayer guy, but still, whenever people say that everything will be automated, here is the problem I think will always come. The problem understanding, automation of the problem understanding will not be that easy. The framing of the problem in mathematical structure after understanding the English is not something which will be very quick to do. We will need too much training to understand and automate this piece. Right, so problem understanding is main part. Many times I have seen we have understood the problem wrongly and went ahead, did all the model building activities, and then realized that, oh my god, everything is not correct. Whatever we are doing, everything is gone for a waste. So problem understanding is the best, I mean, most important piece in the beginning, so that you can convert that into mathematics, economics, statistics. When I was at IT, my professor always used to quote one example, that whenever I used to ask my son to buy some vegetables or some apples or some fruits, I used to give him money, and then I used to tell him that if this costed this much and that costed that much, how much money should be remaining with you? He always used to ask, don't tell me all those stories, just tell me whether I had to subtract or I had to add. It means the moment we only want to know whether I need to add or subtract, we only are technically sound, but we do not know how to convert the actual problem into the technical problem. So that piece is very important, and it really requires too much time and attention with the and the discussion with the customer, with the stakeholder, SMEs, and so on. So do pay attention to it whenever we are trying to solve not only a forecasting problem but any machine learning based problem, right? And if you double click on this forecasting delivery process, you will, again, I tried to replicate the same piece in a different format. That okay, it how things comes if you have to now build the problem, data science problem or machine learning problem, not deploying, not data management, I am saying. So it is like you will have to acquire the data and define business rules if there are any. Then you need to install, say I am trying to run ANN, artificial neural network, and trying to use Python or whatever. Then you to understand where you are going to, what platform are you going to use, what technology are we going to use, or Python, say. Then we need to do data processing, impute missing value, outlier treatment. All those things are part of data pre-processing, right? We need to do something, maybe data normalization, and all those things will happen. Once data is ready, then you come down here. Now here the piece will be split the data into training tests. Again, as I said, we should not actually do training test, but ideally we should be doing training validation test. But people do training tests just because they think that they should not miss too much of data because of testing. They should use most of the data for training. So training test will happen. Then you build machine learning forecasting models. Then you, after training, you predict the values for the test data. Then you evaluate based on different metrics. And then you will compare the performance, and then you may have run many models and you will choose one of them and you will proceed. This is the science piece I'm talking about. No deployment time here. That's why I said it is the double click of the previous slide. So data platform, data pre-processing, data breakup or split of the data, model building, evaluation, final selection. Final selection, right? So this is like double click of the previous slide. So this is the complete, I will say, the approach when you start from a business problem and you want to reach to the final goal. Now I'll just give you a glimpse of some of the, one of the data that it's a very old data, but I just wanted to understand that, do we understand this, what is happening? So this is the demand sales data for a CPG industry, and this is monthly data. So this data, what do we actually notice? We notice that during December, everything is less. Things are relatively sliding mode, but suddenly in August 2012, it is very high. And you will see that graph is not very, I will say, complex or very erratic. That will not smooth, some smoothness is there. Now same data, I am plotting in weekly fashion. Do you see more disturbance, more erratic? Yes, because there are now more points. That is why what I'm trying to say is that lower the level, more will be the disturbance, and difficult will be the to catch and meet the actuals via forecast. Now, even the third one, now I have plotted the same thing daily. Now it is having more disturbances because now it is at the daily level. So monthly, weekly, daily, same data in 3 scenarios. I know pattern will be similar. But when you are trying to meet the numbers at monthly level, I mean, for example, somebody wants to forecast monthly expenditure. It's not that difficult because you will see, you will just just pay attention to your last 1 year's monthly expenditure. But if you are trying to forecast your daily expenditure, it is not that easy because someday you may have eaten in a restaurant and same day next month you will not eat, and hence your match will not be great and you will have huge error, right? So matching at granular level will be very tough. So monthly, weekly, daily, I just wanted to show you some data in this. Now the same data, if I look at in terms of month and in terms of left is month and right is the weekdays. Sunday, Monday is on the right and January, February is the month. Now this data will tell you that, okay, even the quarter and month are behaving differently. It means there is some piece of seasonality sitting in the data, right? For example, if you look at the right graph, Saturday and Sunday is very small, but at the same time, December and November are small, right? So seasonality is also one of the important piece whenever you are trying to forecast the data. Again, I'm just trying to show you that there is seasonality in the data, and we'll understand what is seasonality and different components in a time series. But yeah, now seasonality comes, say, monthly. I mean, maybe right hand side, if you see it, it is coming up weekly, then it may be yearly and all those. But there is something called cyclicity, which is not regular. They come as a surprise and there is no actually time pattern associated to it, right? Now what happens is, what do we actually mean by when somebody says you have to do forecasting? If somebody says we have to do forecasting, what that person actually means? It means the blue curve, entire part is past. It means I have the past curve. I am now sitting at now. Now I need to extend this blue curve in the right panel. Now right panel is in time frame, it is future. So if I am able to extend this blue curve to the right piece, right part, actually I have done the forecast. So left is past, I am sitting, that standing line is now, and I need to forecast the future, right? So this is what the simple task is to extend this graph to the right. And whenever we will be there in the actual, we'll be compared with our extended graph versus the actual graph, whether we are close enough or not, right? Now, different components that are there in the time series, or I will say, whenever you are doing forecasting always means the data is time series based. Week 1, week 2, week 3, day 1, day 2, day 3, year 1, year 2, year 3, right? So whenever we will have time-based data, and there is a difference between time-based data and the regular data. Regular data is like y is a function of x. So y can be on the same time period and x is also on the same time period. For example, y can be sales of a product in week 1 and x can be the price of the same product in week 1. And you can establish a relationship between Y and X. This is not time series based relationship. But whenever we have time based data, the forecasting should always be done with the piece that data is at time based, and there can be a different interpretation if we do not understand this as time based, because expenditure of your last month may be dependent on the expenditure of your expenditure of your next month may be dependent on your last month or the current month. So past influences the present, and this present and past together may influence the future. So whenever data is sitting at time based piece, we say we should be using the terminology forecasting. Otherwise, people generally use the word prediction. Prediction is when you don't have actually time based data. So very subtle difference when we use the word forecasting and when we use the word prediction. That okay, if the price increases, what can be the sales? This is prediction. But now the time based data is there, and then you are using even that information that yesterday this much was sold, then how much will be sold today. Then it is like you are using time as the one of the factor here, right? And time is always a very important piece in any study, whether it is mathematics, physics, data science. Time is very important. Whoever has studied physics in school, nobody would have read dt by dx. Everybody would have learned dx by dt, dy by dt, dp by dt. I don't think we have ever read dt by dx, because you cannot differentiate time with respect to anything, right? Again, maybe it's a digression for those who have not gone through the physics class or the maths class there. So time is the most important independent variable in nature. It is called as most independent variable. It affects other, nobody affects the time. So time is one of the most important piece, and whenever the information is given to us at time level, please leverage that information that it is at time level. How can I use the property of time in forecasting or in my prediction, right? So whenever forecasting what comes, just think that you may have and you should have time data at the time level. The only requirement or the necessary condition is that whenever you are trying to do forecasting using time based data, make sure that data is available at equally spaced time level. It should not happen that you have data for January 1 and then you have data for January 3 and suddenly you have data for February 1. No, this is not equally time spaced. If you have monthly data, you should have all months data in continuation. If you have weekly, all weeks in continuation, whatever, maybe only 10 weeks, but they should be in continuation. So equally spaced data should be there with respect to the unit of time. That time can be, unit of time can be hourly, daily, weekly, monthly, yearly, anything. Only thing it should be equally spaced. And then only we'll be able to use the component of time in our forecasting. As I said, time affects everything, most of the things, right? And nobody affects time. That's why we never differentiate time with respect to anything. We always differentiate everybody with respect to time. Dx by dt is velocity, dx square by dt square is acceleration, and dxq by dtq is even jerk, they call it, right? The third differentiation, although we don't use it much. So time is important, let us use it. Why only physicists? Even data scientists should be using it as much as possible, right? And whenever we think of this time based data, so whenever we are doing forecasting, just think of these 4 P's. Mostly everything is answered by these 4 P's: level, trend, seasonal, and random. Now what is level? Level is like at what level are we standing at? Somebody is asked to forecast the India's population in 2030, obviously that person should not forecast is at 1 crore. Why? Because the level, there has to be some level to it, right? So it is like, we know that we are sitting at 138 crores. So obviously 1 crore is a wrong level that we should start with. So it's a wrong level. Similarly, nobody should forecast the price of, say, Maggie as for 2023, price of Maggie has just increased its price, right, by from $12 to $14, 12 rupees to 14 rupees, that small pack. Now suddenly somebody is asked to forecast the price of Maggie in 2023. We cannot say that it will be $100. No, there is a level already attached to this data. The level is around 12 rupees, 10 rupees, 12 rupees, 13 rupees, 20 rupees at max, right? There is a level. So level is one of the very important aspect, and we should know at what level are we sitting at, right? So this is the starting point in any forecasting or any guesswork that you have to do whenever you are asked to forecast something, right? Somebody will ask suddenly in an interview, I mean, how many airports are there in India? I mean, we cannot just randomly say 1 million, right? We know there are not, there is even 1 million cities in India, right? So there is a level that comes to your mind. So that level should be the something which is not trend. It is just the platform or the beginning point where we are sitting at. If I have no information, what should be my, what if I don't have any extra information, I just have the history and just I have to guess, what should I say? I will just take the average of everybody, every history number, and I'll report that, right? So level is like that. So level is the starting point. Okay. After level, maybe we'll go to the next piece and we will understand again. Sudeep, I will say that let us take even 10 more minutes break. I think maybe people would have.
Yes, Rajeev, right time to take a break. It's 11:55. Should we come back at 12:05?
Sure.
Perfect. So let's do that, and quite a few questions as well. So
yes, I will look into that and I will try to answer.
That should be good. All right. So we guys, we take a break of 10 minutes. Return back at 12:05. Please don't log off, and we'll start exactly at 12:05. Thank you.
Okay. Some of the questions I could see there. Yes, Soumya. Yes, it was the Gurubi solver that we actually tried. That only could solve our problem in case of optimization with millions of constraints available, right? Second is on the question around the multivariate time series forecasting, right? So multivariate forecasting means there are two, although I was starting from the scratch, so I was not planning to cover it unless we finish everything, but I mean, no worries, let us try to understand multivariate versus the other piece that people always talk about. So one is univariate, right? So you will be given sales of a product, demand of any service or something, one variable, weekly data or monthly data or say daily data, whatever. Using that series, you have just one column, one series. Using that series, you need to extend that series. Say that series is only 100 rows. We need to have this for say next 20 rows, or maybe next 50 rows, or maybe next 100 rows. You need to extend it, right? That is univariate. Then how do I make that model, that univariate model? That univariate model means, it means the row number 101 will depend on row number 100, maybe 99, maybe 98, don't know, with some calculations, right? Similarly, row number 102 will depend on the past and so on, and we'll keep on extending it. Now, the moment it comes to multivariate, there are, as I understand and I describe, there are two ways of multivariate. Okay, two ways of multivariate. First, which is you will have two time series with you. You will have two time series with you. It means you will have two columns and both are time series. Okay. First can be the, again, I'm just giving an example. Let's see if we all understand this. First column can be sales of or demand of a product from Big Bazaar, of a particular product from Big Bazaar, say tomato sauce, Kisan tomato sauce, right? Ketchup. So I will have weekly demand from Big Bazaar as first column. And second will be shipment, weekly shipment done by the manufacturer to Big Bazaar. Both are time series. That what is the demand at Big Bazaar weekly and what is the weekly input that Big Bazaar is getting from the manufacturer. Both are week-wise data. I am trying to forecast one or both with the help of both. That is one type of, I will say, multivariate, when you have more than one variable. It means your demand at Big Bazaar will become function of historical demand of Big Bazaar plus function of historical demand of or historical shipment from manufacturer to Big Bazaar. Similarly, future shipment from manufacturer to Big Bazaar is equal to some functions of past shipment to Big Bazaar plus past sales or demand from Big Bazaar. Right? This is one piece people understand. This is called in terminology vector auto-regressive method, or maybe it has and it has more variations, vector error correction models and many things, right? So this is like multivariate when you have more than one vector. Now comes the second part or the second type, where you will get, again I will tell you the same example, similar type of example. Demand of Kisan tomato sauce weekly demand is your column 1, and second column will be the TV ads of that same tomato sauce at week level. Maybe how many times the TV ads comes or what's in the TRPs. Assume that that information is there. Now you have two informations. One is dependent, another is independent variable, right? Now here I don't want to forecast, for example, TV ads, or maybe if you want you can forecast, and if you want you can forecast if you don't have information. But it may happen that for future you will be given that what is going to be my TRP or what is going to be my expenditure on TV ads for say the entire 2022, rest of the 2022, and using the history can I predict the models. So tomorrow when we will be discussing ARIMA models, no, I will add this multivariate piece there, and we'll try to give it a conclusive color, right? So if you have only one, it is ARIMA. If you have independent variable also in it, it is called something else, right? It is actually ARIMAX. X comes into the picture, right? So we'll understand it tomorrow how and how it works. Okay. I assume I tried to answer somewhat Adhikari's question. Then Manish, your answer is also covered. As today or tomorrow we will do and understand multivariate. Okay.
Rajeev, if you can mark them answer live, that would be good.
Okay. So I have done that.
You done that? Okay, sure.
This okay. I mean, there are 1-2 more questions remaining.
Sure.
So let me, on seasonal basis, the call volume has increased, then the normal trend of volume. Then the normal trend of volume, do we have to normalize? In general, Pranav, the idea is to try both and see which is giving us us a better forecast. We will anyway try to rely more on recency than the too much of history. But yes, if playing with too much of history is giving me better accuracy in near term, maybe we'll go ahead with that. So accuracy metric, we'll compare and see who is working better. Okay. Okay. So I'll assume that we understand the level piece, and you can see that level, the first graph on the right hand side, you will see that level means at what we are standing at. It's like everything is same. So now the second piece comes in any time series data, or in any data I shall say, which is time based, whether it is time, whether time, how much time affects it. So there is trend. It means with respect to time, does it increase, decrease, and do we see any trend to that? See, trend is little different than seasonality, right? Trend is like increasing trend. India population has an increasing trend, right? It is like it will keep on increasing. So it has an increasing trend, right? Consumption of Colgate toothpaste is increasing trend again, and it is just because the population is increasing. Not only because of others, but also because of the population is itself increasing. So obviously we'll need more consumption, right? And there can be other factors also, but I'm saying that it has an increasing trend. So many things you will see that it has an increasing trend. Most of the things will have increasing or decreasing trend. Very few things you will find that it is stagnant. Third piece is called seasonality. Seasonality is the third graph that you see, that it peaks sometimes and it again goes down, again peaks, again goes down. Similar, for example, sales of ice cream, it will peak during summer, it will fall down during winter, and so on, right? So it depends. So seasonality will be there. Now whatever is not explained, or whatever is not level, whatever is not trend, whatever is not seasonality, the other piece is we cannot explain, and that is what we call it random fluctuation. In statistics, in mathematics, it is also called as noise or white noise, right? In probability theory, it is called as white noise. So something that is random and it doesn't have a pattern to it. Random means there is no pattern, right? So random means there is no pattern. So whatever is say recognizable, like level, trend, seasonality, we'll recognize that. But whatever is remaining, it means it is random. I mean, we cannot explain it because it may be just by chance. It is not something that we know that it will happen, right? That's why the fourth piece. Now there is, as I said in the before taking break also, that sometimes cyclicity comes, but we may not have information about the cyclicity. But just for sake of visualization, I kept this, that this is Federal Reserve, and it is, you will see that it has data is from say 2006 to 2010. You will see that 2008, between 8 and 9, it has gone down, and we all can associate this to the recession we witnessed in 2008 and 9, right? Because of Lehman Brothers collapse. So that is cyclicity. This is the cycle, it will come and it will, but it is very hard to answer cyclicity because we don't know when the next recession will come, right? If we know something, some intensity, we can try to use this, but it is very hard. So we generally take level, trend, seasonality, and we move ahead. Okay. Now we will come to the problem in this workshop that we will be trying to solve for. Okay. It is from one of the financial service company that is facing challenges in managing its pool of resources, supporting manual reviews of alerts. I will tell you about these alerts. What this company does is, it's a payment platform. Okay, you can utilize that platform to make the payment. Now we all have seen last 1 month Ukraine-Russia war is going on, right? And because of that, the money that you will send via platform, this company's platform, if that money is unusual transaction, so it should not be, so there should not be a chance of that we are doing something which is illegal in nature. We are transferring money. I mean, you are on the border of Ukraine and trying to use your money for your purpose, but the transaction is unusual, then it gets generated as alerts. And those alerts will be resolved by manual efforts. They will scrutinize, check, okay, this is not a wrong transaction, it's a correct transaction. So everything will again come in place. Otherwise, your payment criteria will be stopped, and there can be many implications to that, right? So sanctions is a terminology being used that if a place is sanctioned, if a country is sanctioned, you cannot and you should not transfer money using the platform that financial company is offering. So this is from the sanctions domain, and in that many transactions are now getting described or they are being told as alerts. Many alerts are getting generated because of that transactions. More transactions are happening, and since it's a relatively sensitive time, so more alerts are getting generated. Now alerts are getting generated, so it means you need manual effort to resolve that alert. Now, unless I know how many alerts, how will I know that how many people should I keep to resolve that, right? So it means we want to forecast what would be the volume of alerts generated for the manual reviews. And then next step would be to plan these resources accordingly, right? I mean, how that planning can be done. Now, the data we have, the data that we have is from 1st January 2018 to 30th January 2022. That's why our data doesn't have, this data doesn't have that Ukraine effect, Ukraine-Russia effect. So assume that that effect is still not there, and then we will solve, and then we'll think how to solve when you know that there is a problem in Ukraine and Russia. Okay, first assume that there is no war there. We have data till this time, and we are sitting on 31st of January, and we are trying to forecast the number of alerts that will get generated on daily basis for, say, next, I mean, we can decide 12 weeks, we can say, and then we'll see how many people are supposed to be there to solve for those manual reviews, right? This is the problem statement that I have at hand, and we will try to solve this or forecast first. First task is just to forecast. Make sense or it doesn't? It does. So some of the basic, again, I will not do the calculations for this, but for the sake of completeness, I just thought that we all should understand that what are the basic methods that people start with. That, okay, when you don't know any complex or any complicated time series based models, very basic models, where do you start from? So my first response is that, okay, when you know nothing, let us assume that whatever is there in history, everything matters. Everything matters. When everything matters, it means forecast will be average of everything, so that I am giving importance to everybody. I will take average of all the history, and I will say this is going to be your tomorrow's forecast. This is the method one, most basic one. Many people report it when you have no information and you just want to give your first, I mean, you have just 10 minutes and you have to generate one number. What will you do? with the data that I have. We'll do this. Or maybe you have 2 minutes. This is what we can do the best. Now, when only yesterday matters, so assume that I am giving most important to the most recent data. So only yesterday matters. What will I do? I will say whatever is the number yesterday, I will forecast this for today. Or whatever is the number for today, I will forecast this as if it is tomorrow. Right? And then the third is you can make a version of number one, when I say everything matters. Okay, not everything doesn't matter. Maybe some part of the history matters. Right? Moving average. Maybe last 7 days is important. So I will take last 7 days in forecast average and forecast it just tomorrow. Right? Most basic. We will not do calculations on this, but I just wanted to make sure that when I said ground level 0, this is ground level 0, and we can start with that. Generating the number. I will suggest that even our workshop is done, let us use all these methods and see which is performing at what level, and we'll understand what do we mean by performance. Okay. Then when the first 3 methods that again I have listed here, the everything matters to yesterday matters to say moving average, all these things may be very easy, obvious, but may not be good enough. Because we may see that, okay, there can be some other relationship. You cannot give equal weightage to last 7 days or 3 days. Can we do something else? Right? So what we can do is, there is something called, here actually people start saying that, okay, I am using machine learning or statistical based models. Okay. This is called exponential smoothing. Exponentially smoothing. The first piece is actually called as convex combinations of today's actual and today's forecast. Okay, today's actual and today's forecast. So it is like, if you look at the last line, I am trying to forecast. Left is the forecast. And how have I forecasted? A times actual of time t plus 1 minus a times, and when I say a, actually it's alpha times x times xt plus 1 minus alpha times the previous forecast. Right? So it is like, if I have to forecast for tomorrow, I will take today's actual and what I had forecasted for today. Both convex combination. In mathematics it is said, but you can just think of alpha times today's actual plus 1 minus alpha times today's forecast. And this alpha ranges from 0 to 1. This is called the first exponential technique that people use, and it is called as single exponential smoothing. And what do we mean by single exponential smoothing? It is because I have just single parameter. Single parameter is, and that parameter here is alpha. Alpha xt, 1 minus alpha x cap. X cap is forecast and x without cap is actual. So tomorrow's forecast will be alpha times today's actual plus 1 minus alpha times today's forecast. Single exponential smoothing. Right? Now, I will suggest that everybody, we can all, Sudeep, can we everybody access the data?
Yes, I can share a link on the chat.
Okay.
And 1 second, let me do that quickly.
Sure.
And this will have the data. Right? 2 data sheets are there.
Yes. So firstly, I just need one data set, the alert volume. There is a
you
data
just
called
need
alert
one.
volume.
I put both of them together. Is
Okay.
that fine?
No, yeah, it is fine.
Sure. So I'm just sharing it on chat. Yeah, this is the one.
Okay.
I would request everyone to go to this file. It has free access, sorry, for everybody. You can download both the data sets which Rajeev is going to discuss about. Yes, Rajeev, you can go ahead.
Okay. So when we have access to this data, you will have access to column A, B, and C. This piece is coming from your data that is there in Excel. Okay. I'm assuming that we all have access to that data and we have this file open. Not this file, the file that I have, not this one, but the column ABC. Since I don't get in, I don't see any new question, so I'm assuming that we all have access and we don't have a problem. Right? Now, in your Excel, if you click on data, okay, if you click on data ribbon, do you see anything called solver at the end? Everyone. If you click on data here, I have something called as solver here. If we do not have, then I'll tell you how to get to that solver.
So maybe people can respond on chat saying that, you're not able to see that, and Rajeev can guide us getting that function. Yeah.
Okay.
So I see
Sandhya
Sandhya
says,
mentioned.
okay, so we don't see. Great. Okay, nobody is able to see. Okay, so what we all will do is we will go and click on the file. Click on this file. In this file, you will go to the end and you will see something called options. Click on that options. And this screen will come. Okay. Go to file, click on the options. This screen will come. In this screen, second last, add-ins. You have to click on the second last, add-ins. Okay. Once we have that add-ins, we will go and click on this analytics tool pack. Add-ins, analytics tool pack. And then we will go down where it is written manage Excel add-ins. Just click go. When you will have go, this will get open. Here you just click solver, and just for future use, sometimes you want to use analytics tool pack, just click on analytics tool pack and solver both and click OK. Then whenever you click data, these two data analysis and solver should come at the last block in your Excel. Let me read the question. Yes. Okay. Can I assume that we all have solver add-in now?
Yes, I could also I was also able to do it. So
okay. Thanks, Sudeep, for the confirmation. Okay. So now we have that solved. See, what I'm trying to do is the most basic, say, single exponential smoothing. I'm just trying to make sure that it is not that RStudio will solve our problem. RStudio just makes the things faster. We also can always do it. We can just give commands to Excel and it can be done. Okay. Now in the same sheet where you have this data A, B, C, okay, go to column H like me, and you can give it a name alpha, because we were using alpha as the parameter for single exponential smoothing. In column H, just first one, you can write alpha. Okay. And you can just give a value. You can write 1. We all. Now, once we have that piece, now based on this alpha, assume that this alpha is 1. If my alpha is 1, what is going to be my forecast? Now, first day forecast anyway, you cannot do because you need history. And your day starts on the day 1. So first day, we will not do any forecast, or what we will say is my first day forecast is same as the first day actual, because I'm not doing any forecast for the first day. So my first day forecast will be same as, so you create one column called D, which is forecasted alert volume, or whatever name you want to give. It is fine. You don't have to copy or follow my nomenclature. You can write just a name forecast in column D. First day forecast, you simply write equal to C2, because it is actually equal to the same day's forecast. From second day, I will use the equation that I had said in the PPT, and the same equation is also written here. Alpha times YT plus 1 minus alpha times LT minus 1. Right? And when I say LT minus 1, it is just like forecast. Okay. So if you go to D3, if you write this equation, H2 $, I am saying because my alpha should not change. That's why H column is for alpha. It should not change even if I change the rows. That's why I have made it $. C2 is my current actual plus 1 minus alpha times previous forecast. Sorry, previous actual, H2 into previous actual plus 1 minus H2 into previous forecast. Right? Don't drag it. I'll tell you when to drag. Don't drag it. Are we all aligned? If anybody is not aligned, please ping me on the chat and I'll see. Or even Shantan can help us. So if we are able to write our equation in D3 as a forecast, we are good for now. Are we done? Okay. Now, if this is my forecast, my column E becomes error. You can give it a name error. Error is nothing but actual minus forecast. So I am just writing C3 minus D3 or C2 minus D2. So you can write C2 minus D2 and C3 minus D3. Right? Then I will use the square of the error. Okay. So it means ABC I already have. D, E, F, I can populate completely. Don't do it now. I will tell you when to populate. Don't do it. But I want to make sure that we all have formulas written in row number 3 and all these 3 columns, D, E, F. Okay. So I don't see any new message. So it means we are good to go. Right? Now, this data set, as I said, my data range or data date range is 1st January 2018 to 30th Jan 2022. So you will control arrow down arrow, you will see that in your data, you will see that your data is ending at 30th June, right? You should have this. Okay. Now this is the data's entire data. We should, before doing the modeling, we should always break it into train and test, right? So assume that what we have done is yellow part is my test and white part is my training. It means data till 31st October is train and data after 31st October is test or validation. Okay, again, I have just colored it yellow just to make sure that I am able to identify. You may choose not to do yellow color or whatever you want. Okay, so my training is till 31st of October. So I will suggest that you drag your D3, E3, F3 till that row. And that row is nothing but, I think, 1398. Right? Drag it till 1398. Where your training ends. Okay. I have many questions. Let me see. For column F, yes, for column F, it is E square. Correct. Okay, can we have the look at the formula for this one? No? Yes. Formula is H2 into C2 plus 1 minus H2 into D2. H2 into C2 plus 1 minus H2 into D2. Only thing is that this H you need to pack so that when you change the rows, the value, alpha's value doesn't get lost. Right? Yes, now you can drag the numbers. Now you have to drag the numbers to till row number 1398 because our training data ends on row number 1398. So drag till 1938. Right? Once we have dragged it till 1938, it means I have error square for every record in my training data. Right? I have error square, that is column F, for every record in my training data. And my training data is from 1st January 2018 to 31st October 2021. Okay. So if my error square is generated, I will generate something called RMSE, root mean square error. RMSE is nothing but a very standard error metric which is called as root mean square error. That's why we have already taken square error in column F. Now what I am doing is I am taking mean and then taking root. So you have to use only training data. That's why in the average function you will use F2 to F1398. Let me see message. For me, it's alternate cells for error. Whatever. I was just trying to make sure that you follow my row column so that we all can be on the same page. Otherwise, you understand the calculation. I'm fine. Right? So error square is in column F. In column G, what I am trying to publish RMSE. That is nothing but average of the square error and then take the square root of it. Even if you don't take the square root, it is fine. I am only taking it just because the number doesn't look very huge. Take the square root, and if you don't take the square root, it will be called as MSE, not RMSE. It is called MSE. Right? It is called MSE. So if you take the square root, it will be called as RMSE. Data is not showing in all the, no, data should be shown in all the fields, right? In all the rows, all the columns from A to F. Row number is A to F, and row number 1 to 1398, everything should be filled from column A to F. Column G, I just need one number. Column G doesn't need to be dragged. Column G, I just need one number. Let me know if everybody is on the same page and everybody is getting this number 2662. Everybody should get this number 2662. Otherwise, there is something different.
Rajeev says, sorry to interrupt. I think there's a typo there in the LT formula. It should be YT minus 1.
YT minus.
So in the formula that is written, not in the cells. It's in the column HLT.
Okay, here.
Yeah.
Now again, I'm not worried about the formula. That is fine.
No, I think people are using this formula to create the Excel formula. So there might be a mistake.
Oh, is it? Use this formula that again, HT into CT, right? HT into C2 plus 1 minus S2 into D2. 2662. Everybody is getting, or their numbers are different. Somebody is getting 2655. Again, it's fine, 2661 if you are getting, because decimals may. Everybody should be getting 2662 or 2661. All right. Again, alpha should be 1. Formula should be H2 to C2, and here it should be F2 to F1398. F2 to F1398. Right? Again, I mean, number 1 and 2 may not make a huge difference. We can always check it, and you should see that it is 2662. Correct, 2661.3. It's fine. Okay. Now, this is my RMSE, and what alpha I have used? 1. So I have used alpha as 1, and using alpha equal to 1, in my training data, I am getting 2662 as the root mean square error. Now, let us look at some of the metric that people use for the error world. Okay. Again, I just changed my PPT. So don't close your Excel because everything is related. Now, in the world of performance, we should try to make sure that we have less error. And when I say less error, there are 4 pictures you can see. And only the first one, not only the first one, only the second one is the best. Otherwise, everybody is worse in some respect or the other. It is like when you are trying to play a dart game. You always want to hit the center and see that there are 4 different players. First player has taken those 10 trials, second also took 10 trials, third also took 10 trials, and so on. You will say that the second player is the best player among these 4. That's what the interpretation should be, looking at the dart games attempt, right? The first one's problem is that it is very accurate. And when I say accurate, means what? That all his trials are less variable. They are all together. It is not that first trial he's hitting east and second it is west, and it means he is randomly trying something. He is trying to aim and he is hitting same point in the first one. The only piece is all his attempts are very away from the actual target. That's why he is relatively accurate, but he's or she is biased. Biased means on an average you are away from that center or the target. Leave the second one for the time being. The third one is again biased. Why? Because it is again everybody is away from the center. But now if you compare first and the third, you will see that all attempts are also not together. They are relatively scattered than the first one. Right? Now, look at the last one. You will see that it is not biased. On an average, it is around the center. But at the same time, it is not accurate because all the attempts are scattered. All these attempts are scattered. The best one is the second one. It is accurate, all are not scattered, and it is not biased. It is hitting at the center. So whenever we try to make any models, I mean, it need not necessarily be the forecasting model. Any machine learning model where we are doing prediction forecasting, it is good to see that these both are in our favor, that we are not biased as well as we are relatively more accurate. So second is the one which we should aspire for. Then the third one is the worst, not accurate and moreover biased. Fourth is still not biased, but again the accuracy is less. First is accuracy is fine in terms of very close, but the biasness is there. Everybody is away from the actual. So we should always aspire for the second one. So whenever you look at the output, always calculate bias. And at the same time, see the accuracy metrics. For example, in our case, our accuracy metric is RMSE. Now I will go back again to that Excel, right? Now the column G, RMSE training, it is the error and it is a measure of accuracy. Bigger it is, less accurate you are. Smaller it is, more accurate you are, right? Now, if I go to column K, if you look at column K is nothing but sum of error of column, the column E of the entire training data. It is the sum of your error. If your error, sum of these error are close to 0, it means your bias problem is less. Higher the number, whether in negative direction or the positive direction, it means you are more biased. See that we all have in column K, if we have around -86, the number that I have got. Do you think we all have got this similar number? Yes, -86. So this is our training bias. So you have your training RMSE, which talks about accuracy piece, and K is about training bias. Right? Now we always want bias to be less as well as error to be less. In optimization, people, in forecasting, people always first try to minimize their RMSE or whatever is the error metric they have decided. There will be more error metrics we'll discuss, but currently let us go ahead with the RMSE metric, right? Now, if you click on the solver, right, do you see something like this? It says set the objective. What is my objective? Where is my objective sitting in? So RMSE is my objective, which needs to be relatively smaller. So it is my G2 is where the RMSE is sitting. Now set the objective 2, the second row. I don't want to maximize my objective. I want to minimize my objective. Right, let me see what is the question. Yeah. Now, what should I change in terms in way of minimizing my RMSE? The only parameter I have in hand is the alpha parameter, which is currently set at 1. I want to see which value of H2 should I try so that my RMSE is minimum. It means my error metric is minimum. So H2 is something that I need to change. By changing variable cells, only one cell I need to change, H2. From 1, should I take it to something else to bring down my RMSE value? And RMSE is sitting where? The objective function piece, G2. Now you need to add constraints. Is there any constraints on your parameter? As I said, the constraint is your alpha should be between 0 and 1. Minimum it can be 0, maximum it can be 1. Right? So that's why H2 is less than equal to 1. At the same time, H2 is greater than equal to 0. So your alpha should range between these. And if you go down here, the select a solver method, you will see that there are 3 different ways to solve it. First is called nonlinear approach. Second is linear programming simplex method. And third is actually called as evolutionary algorithm. It is actually talking about genetic algorithm. And it is mostly used when you have integer problem and so on. You can try, for example, simplex or NLP or simplex LP, and you will see that you have to just click on the solve button. System will start solving and it will tell you a message: solver has converged to the current solution, all constraints are satisfied. You can say keep solver solution. Okay, can you see what the value of alpha it has become? The alpha value is 2325 now from 2662. Sorry, alpha value is 0.031 from 1, and your RMSE is 2325 from your 2662. Right? Yes, Pranav is correct. RMSE is 23. Yeah, 2326, 2325. I mean, just a decimal place because of some error. I mean, Excel. That's fine. So it means if I want to look at the alpha which minimizes my RMSE, it is the 0.031. Right? And now when I have fixed my this alpha, I can go and see what is my forecast. I can drag now to the even forecasting period, right? This yellow piece, and I can see what is my error and all those things, right? And you can even plot and see how the curve looks like. Right? And you can do many things. Correct? Everybody is with me till now? Everybody is with me till now?
Maybe people can respond on the chat, please.
Yes.
Anant is saying, please repeat. Naresh is saying yes.
Okay. So what I meant is with the same alpha that we have just got by optimizing, I can use this alpha now. And I know we had dragged it till training data. Now I will drag even for the forecasting, the testing data, the validation period, right? After 31st of this October 2021. And you will see that these are column D will get populated as your forecast value. Right? And you can see how good your validation is by calculating RMSE for training and bias for, sorry, RMSE for testing and bias for testing. Now RMSE for testing will be how much? If you have dragged, your test data starts from row number 1399 and it gets overed in line number 1490. Right? Make sense? And you will get the RMSE testing data. Similarly, you will get bias testing data. You have bias training, you have bias testing. So it means if you use SES, this is the best parameter. Solver is giving you, you don't need to even attempt RStudio or Python or anything. We can solve it just by using a solver command of Python, and I can get the response for single exponential smoothing. Make sense? Okay, let me see. Sudeep can answer if the recording will be.
Is there a question related to recording? Yes. So as I mentioned, we are in fact recording this session, and there is a module 2 which is happening tomorrow. Again, Rajeev would be taking care of that. So you should ideally register for the module 2 as well. I'm leaving the link here on the chat for your reference. And once the module 2 gets over, both the recordings would be shared with each and every participant. But having said that, don't wait for the recording. Be as participative as possible and make use of this time to ask Rajeev more questions.
Correct.
Rajeev,
So,
would you like to take a small break and then probably finish it? Or
oh, yes. I just missed it. Okay. Yes. So I know. I mean, so SES is almost done. Single exponential smoothing using Excel. So I think we should have confidence, and we'll quickly come and do DES. The second, when we meet after the break, it will not be a long one. So we'll try to wrap up in half an hour, and then maybe we'll meet tomorrow.
So it's 13:03 or 1:03 at my watch. Let's come back at around 1:15.
Yes.
Sure. Okay.
Thank you.
Let's get started. And just want to let you guys know that I've also shared a feedback link. So if you can share your feedback about today's session, there is a link I have shared in the chat. I will share it once again down below, so that you can and it's good for us also to build further programs for you. And we continue this session tomorrow with Rajeev at the same time. We start at 10 and goes on to 2. So look forward to having each and every one of you back here. Do register yourself for this session. And I'm just sharing the feedback link so that there it is.
Okay.
Rajeev, over to you. Thank you.
Yes, sure. Before we proceed, maybe I'll try to answer one or two questions that we may have.
Sure.
Yes, Soumya, the cyclicity in general, this is what we understand, that steel production that you talked about, right? I mean, steel demand will go for a toss in this decade and that decade. So even that there, we don't know where the timing will start. That's why that cycle, we don't know where it will start. And when we know, then from there we can quantify and we can correct our say output. But depressions also we expect that, not depressions but general recessions will come once in a decade and so on, right? So it is something that we don't take care in our, because in general the forecast is short term or the medium term. We generally long term 10 years forecast, I mean, we need to do, but for that we need to really understand, are we very serious about cyclicity, and if yes, how and how much to quantify, right? Then again, Soumya's question is that should we use LP or GRG? Again, whether you minimize square root of MSE or you minimize MSE, the interpretation will be same. But yeah, I know square root is a non-linear function. That's why you are saying that we should use non-linear. Correct. But when you have square root or non-square root, in this case will give you the same interpretation, that okay, which should be your best alpha, right? The direction should be same. So we should actually try both and see which is giving us the better answer, right? Okay, I have some questions on chat. No, I don't have. Okay. Here I'm done. Okay. So here, so everybody is able to generate the RMSE training, RMSE testing, bias training, and bias testing, right? So this is what SES will do. Now, when you go out of the testing period, now it's the real forecasting time. I do not have data post 30th January in my file, but I need forecasting to be done. I need forecasting to be done for those time period, 31st January, 1st February, 2nd February, and so on. We'll be able to do that. So how do we do in case of single exponential smoothing? So the single exponential smoothing just means that the last forecast that you have got in your test data with this alpha, that becomes the forecast for the entire time period. Anybody can tell me why am I making this statement? You can chat if you want. What I'm saying is there will be only one forecast for entire time period after 30th of January 2022. It's the same number that will keep on going if I use single exponential smoothing. Again, the answer is same as answer is same as one parameter, right? Single exponential smoothing, it is just using one parameter. And when we were explaining the time series component, we had components like level, we had component like trend, we had component like seasons. So I am just using single exponential. It means just one parameter, alpha. So it means I am just talking about level. So single exponential smoothing gives you level at which you should forecast. It doesn't take care of trend. It doesn't take care of seasonality. So level means just the same level it will give you, and same level we have to forecast for the entire time period. That's why single exponential smoothing is just good for one forecast, very short term forecast. It gives you flat forecast. So we should not rely on single exponential smoothing much, but this is one of the technique people use, right? That's why you will see that you will have the same number, the forecasting time period. If you same number, whatever you have got at the end, this number will be printed everywhere, because this becomes the level. This is my forecast for 31st January based on the 30th January and 4479, and this will continue to be the forecast forever. This is called single exponential smoothing. Now, very quickly, same data set you can copy in the second sheet. This is called double exponential smoothing. Okay. Same data set. Now, only thing is you should have in this column something called level and something called trend and then forecast. Because now I am using double exponential, so our equation will be little different. But I want to make sure that we understand this, and we'll see that the numbers have even become different, bad, worse, or whatever. Or we can choose to do this directly in our studio tomorrow when we start our forecasting on our platform. I just thought that maybe you should know how to do things even in Excel, and you should match your answer from Excel with that of our studio, and you will get the same answer. And Excel is just that you see what is happening, and in R you will not know what is happening at the backend, and your answer will just get published. So this double exponential smoothing will have two parameters. One will be called as alpha, another will be called as beta. So assume that I give same number to alpha and beta, 1, 1. Okay. Then anybody can read this formula for level. It is alpha times current alert volume plus 1 minus alpha times previous alert volume, or I should say alpha times current alert volume plus 1 minus alpha times previous level and trend. Are we all on this page? Or again, it is not necessary that we have to do it on Excel. We can directly do it in our studio. So just trying to understand what is it, what is our take. Do you want to do it on Excel, this exercise, because it will need relatively more calculation than ACS? But yeah, it will tell you training. You will understand what is level, what is trend, and then how the forecast is coming. In the single exponential, forecast is directly coming from level. In the double exponential, forecast will come from level and trend. So we should have level and trend both. I'm just trying to tell you how level and trend are getting calculated. So you can think that first one, level is same as the actual, and trend is the next actual minus current actual. So D3 minus D2. So this becomes level, this becomes trend for this record. Now these two will get summed and output will be this forecast, this level, and then this trend, and then this forecast. So this is how things will keep on moving. I can give you the formula, or you can read formula from here, the level and trend. If you read the Excel, the level is alpha times YT. Again, Y is my actual data. Alpha times YT plus 1 minus alpha times previous level plus previous trend. And current trend is beta times current level minus previous level plus 1 minus beta times previous trend. This is what double exponential smoothing is doing. And based on this, I mean, you can get the output of forecast. Okay. Okay, so we want to do first on Excel. Great. So what we will do is, I know we have data till column D. We will go to column E, create a column called L. First value of L is nothing but the actual D, the actual alert. And when you go to trend, it will be D3 minus D2. It is D2, it is D3 minus D2. And this D3 minus D2, once you have done, then you will come here. Let me know which, ping me, which cell I should be on, so that we all can execute this. Are we all good till now? Column E. First is the same as D2. The second one is K2 times D3 plus 1 minus K2 times E2 plus F2. Okay, done for E2. So let us do for E3. And once you have for E3, it is just like we have to drag it. So if E3 is done for everyone, can I go to F2? Can I go to F2? Ping me in chat if I can move to H2, F2, or I'll be in E3 only. E is about level, F is about trend, right? Are we done with column E? You just need to say yes or something. No, yes. Okay. Yes. So once we are done with E, we'll go to F. F2. F2 is nothing but D3 minus D2. F2 is nothing but D3 minus D2. If I am done with F2, we'll go to F3. F3 is L2. L2 is that beta. And L2, you again, all these alpha beta, you have to jam in Excel. It's like $, fix it. So L2, E3 minus E2 plus 1 minus L2 into F2. L2 into E3 minus E2 plus 1 minus L2 into F2. This becomes my trend. Right? Okay. Once we have this, then you can drag E and F. It's fine. And your forecast. First, Forecast is same as, because we don't have any previous record. So first forecast will be G2 will be D2 only, but from G3 onwards, you will write E2 plus F2, that is level plus trend. Right? Yes, it is shared. Data file is, you must have received one link. Data is shared there. In the same chat, there is a link where data is there. Okay. Please show the formula for again F3. Yes. Sorry. F3. Formula for F3. L2 into E3 minus E2 plus 1 minus L2 into F2. Right? Once you have level and trend, you will have level plus trend equals forecast, except for second row. Second row forecast will be equal to actual. And once you have forecast, you know how to calculate error from your earlier file. You know how to calculate error square, and you know how to calculate RMSE training. Sudeep can ping again to you that, or somebody else can ping the data. Okay. So once we have this forecast, once we have this error, once we have this error square, we will have this RMSE training. And this RMSE is based on alpha equal to 1 and beta equal to 1. Right? Again, I can go to data. I can open my solver. In this solver, I want to minimize J2. J2 is my RMSE training.
I just shared the data link with everybody.
Okay, thanks, Sudeep. I think somebody was asking for that. So J2 will be minimized. That's why in the 2 you have to click on min. And what I need to change? Now I need to change 2 parameters by changing variable cells K2 and L2, because I need to change alpha and beta. I want to understand for both the combinations which will give me best answer. And the conditions is all K2 and L2 both should be less than equal to 1 and greater than equal to 0. Right? There was one question around, I missed to I think answer that. That why alpha is between 0 and 1. In single exponential smoothing, double exponential smoothing, all these things, we are trying to take convex combination of actual and forecast. Okay, and convex combination always means alpha between 0 to 1, and if one is alpha, the other will be 1 minus alpha. So that if one is 70%, the other is 30%. One is 40%, the other is 60%. So the total percent should be 100, that distribution. So at max, you can give full weightage to the actual, or at worst, you can give full weightage to the forecast, right? Because it is alpha times actual plus beta, 1 minus alpha times forecast. That's why convex combination always means alpha should be between 0 and 1, so that 1 minus alpha can also be between 0 and 1, and at the same time the total sum should be 100%. Right? Okay, let me see if there is any question. No, right? Okay, so once you have done that, then again you just need to, why it's not, yeah, again you need to go for the solver and you will click on solve. You will see that alpha and beta both are getting, so solver comes and gives you some answer. So it says take alpha equal to 0.12 and take beta equal to 0.21. right? And this is how you can establish your alpha and beta, and then you can even forecast for the validation period with the same alpha beta, and then forecast for the even future. And you will see that now your line will not be level, but your line, now your forecast number will have even level plus trend. So it will have a declining trend or say increasing trend. Again, we are doing this on Excel just to make sure that we understand how the operations are being done inside to do the exponential forecasting way. Otherwise, we can directly go to our studio, which we will be doing tomorrow. We'll start with single exponential. We will then go to double exponential. We will in fact do triple exponential also. It's like seasonality, bringing up seasonality into the place. Once we will do that, we'll compare these three, and then next we will go to ARIMA method. Okay, we'll go to ARIMA and we'll see how these four are performing, which one should we select and proceed on. Right? Anybody is stuck on this Excel or wants to understand more about it, this Excel? This Excel was just to showcase that calculation can happen in Excel also for the exponential smoothing processes. I just need R Studio. In that R Studio, we will tomorrow talk about if there is any libraries we need to install. Okay, Anant, makes sense? So R Studio should be there installed. That by default should be there, R Studio. And then maybe we will have some libraries installed once we move ahead. Okay, for example, I mean, packages like forecast, time series. Tomorrow we'll discuss what to install, and then based on that, we will forecast. Formula for G3 and G4. G3 is E plus F. From G3, everything is E plus F. Forecast is level plus trend in double exponential. Okay. If not, formula is here also. Y tilde is the forecast. Okay. So one can compare different methods and then arrive on the best method based on the accuracy, right? So what I'll quickly do is I will just walk all of us through some of the SES again and bias training and testing if time is there. Yes, David, I know you had problem in as you were using Mac and the add-ins were not working properly. So if I go to SES, so let's go to SES if it is required. So in SES, till column C, everything is data. In column D, first will be same as C, D2 is same as C2, but after that D3, it becomes H2 into C2 plus 1 minus H2 into D2. And in H2, you need to have the alpha value stored beforehand. And then we will do the optimization. Right? Now this thing can be dragged. So entire D can be dragged. E is nothing but C minus column D. It's like error. F is square of the error. And then G is, I'll tell you when we reach there. Okay, David, does it help? Yes, okay. So once you have this, then error, and then RMSE training. The moment you go to column G, you will have square root of average F2 to F1398. F1398 because my training data is ending on row number 1398. That's why this RMSE. Yes. And then you will do the solver piece. You will go to solver and you will add the objective function G2, change S2. S2 should be less than 1 and S2 should be greater than equal to 0, less than equal to 1, and then run the algorithm and we should get the answer. Right? Okay. Okay, so I think we understand SES and DES. There is something called TS in Excel. We can do that, but maybe it will become more difficult because seasonality also comes into the picture. Comprehension may take time. So we'll directly do that in our studio. So in our studio tomorrow we'll do SES, we'll do DES, we'll do TS, we'll do ARIMA, and then we'll understand which is better amongst those four. Right? Any question? Let me see if there is anything. Yes, I will share this also. So tomorrow you should have access to this also if you want this Excel. Okay. Okay, since we are all doing forecast, just before we all leave for the day, tomorrow when we come, I just need to understand if we can guess, assume that there is a data given as first record is 1, second record is 2, third record is 4, then it is 7, then it is 11. What is going to be the next record? Let us attempt. Somebody should come up with the response. I know many people would have got it now itself, but you understand? So the 1, 2, 4, 7, 11, what is the next number? So assume that this is my time series data. 1, 2, 4, 7, 11. Next is what? Right? And we can start with this discussion that what is the answer? Okay. Oh my God, answer has already come. One answer is 18, one answer is 15, one is 16. Okay. Okay, we'll discuss tomorrow what is the correct answer and why. Okay. We'll discuss this tomorrow, what is the correct answer and why. Okay. Okay, quickly show formulation of bias, training and testing. Okay, bias is nothing but sum of all the error. Sum of column E in the training is bias training and sum of column E for testing period is bias training error. Okay. So let us understand. Many people have answered this 1, 2, 4, 7, 11. I will not say whether that is correct or or not. But yeah, let's see if tomorrow we can discuss this. Okay. So Sudeep, so better we call it a day, and maybe tomorrow we'll start with our studio.
Sure, I think that makes sense. And frankly speaking, very interesting session for a person like me who doesn't deal with a lot of data. Yes, doing it on Excel was definitely something interesting. I hope everybody liked it and have also shared their feedback with us. And do register for the session tomorrow. And I'm looking forward to having Rajeev once again tomorrow, and we look forward to having everybody back tomorrow for this session. All right. So Rajeev, thank you so much. And with that, I'm ending the session now.
Sure,
Thank you.
Sure. Thank you. Thank you, everyone.
And thanks to Shayantan as well.
Thank you.